graphene is this extraordinary one atom thick, incredibly strong material. An incredible material in terms of its optical and electrical properties. And those properties make it a wonderful starting material for building more complex shapes if you can deal with it in a controlled way. So when we first started, we began with large sheets of graphene and we would just poke at them. It's one thing to see numbers on a page that tells you graphene is incredibly strong and incredibly resilient, and it's another to crumple it up like a sheet of paper and watch it return to its original shape. And over time, we realized that graphene behaves a lot like paper. So the first thing that I remember us trying was a in-plane spring. So it's basically a whole bunch of offset cuts that allows you to stretch the graphene or the paper. And it was labeled as a children's kirigami decoration, the easiest hanging mobile. So we took what was considered the simplest kirigami model and scaled it down to a one atom thick sheet of graphene and created an incredibly tiny, incredibly resilient spring. We can make pyramids out of plane springs that create sort of a three-dimensional shape that you could imagine setting down on top of something. We've cut spirals that if you pull up on the center, it creates this beautiful mobile shape. The other thing is that all of the stuff we've talked about so far involves taking a little needle on a robot and pushing and pulling on the graphene. But you could also start to control it from afar. So you could use magnets and you can control a whole bunch of hinges at the same time, or you could start to twist graphene to create more complex shapes. Mechanical motion at very small scales is still very challenging. Life is very good at doing it. Biology is very good at doing it. And so graphene, by being this incredibly resilient material, starts to allow us to imagine building basic pieces of small machines that could start to be very simple to make, very strong, and could last for a long time.